Yeah, I forgot that I already shared the slide to you. Yeah, so basically what you need to do first is to calculate the sigma, right? Sigma is the n, or we call it f sometimes, divided by a. A is the area. The area is the pi r square. In this case, pi times, what is the d? 25 divided by 2 square. Okay, then you have this, and then you have the stress is 336 MPa. Okay, and then you can calculate the strain. The strain is the delta times L. Delta you're given here 1.22, right? L is 250, and then you can calculate the strain 0.00048, or some people call it 0.48%. Okay, so if you use percent, it's like this. If you don't use percent, it's like this. Okay, and then what you need to do is to check whether sigma is sigma lower than sigma 1, because if sigma is larger than sigma y, you cannot do this. Yeah, this equation only holds for this elastic region. Yeah, why? Because it has a linear slope. Okay, so since sigma that you calculate is 336, while the sigma yield is 440, it means that you're not reaching this region yet. Okay, no. Okay, it means that you're still in the linear region. Then you can use Hooke's law. Okay, Hooke's law says sigma is equals to E times epsilon, and then E is equals to sigma divided by epsilon, which is the one here. And then you can calculate that the sigma is 336, the epsilon is 0.0048, and then you can get the modulus of 70 gigapascal. Any questions? I think several persons answered the question correctly. Okay, now determine the average normal strain. Yeah. So imagine you're calculating the strain. You are asked to calculate the strain. So ring A moves to ring B. Okay. As you can see here, it moves to the left 10 millimeters. It moves downward 20 millimeters. Okay. Can you calculate the strain? Yeah. So the way you calculate the strain is first is that how do you calculate the strain? You need delta L respect yeah, delta L divided by L0. So you need to calculate L0 first. What is L0? It's distance from C to A. Since this is 4, this is 3, the initial length is 5 for both of them, right? And then the final length, how to calculate the final length? The length after deformations. Since this guy moves from here to here, so this is 20, this is 10, all right? You can calculate the length, the new length of LAX and B, LAX and C. So LAX and B, since this moved to the left, so the horizontal distance will decrease by 10 millimeters. That's why you 3 minus 10 millimeters. In the Pythagoras, you subtract 10 millimeters to the 3 meters. And then you do the same thing. How about the y? The y distance, since this is going downward, you add them, 4 plus 0.02. So this is the new length of AB. This is the new length of AC. Okay, clear? Once you get the new length, can you calculate the strain for each of them? It's just delta L AB divided by LAB. Yeah, so it's a 0.01004 divided by 5 because initial length is 5. And you can do the same thing with the LAC. Yeah, and then you will get this. Okay. Any questions? I think it's pretty straightforward. How about this? Let's do it one more. And I think I don't have this. Yeah. So if the load P on the beam cause the NC to displace 10 millimeter downward, determine the normal strain in wire CE and BD. Can you try to solve this? Try it in 3 minutes, okay? And type your answer in the chat box. Just calculate the CE, yeah, the strain in the CE. That's enough. Oh, no. Yeah, try CE first. What is the strain CE and what is the strain BD? Can you solve it? Does anyone get it? It's very simple actually. So now imagine that You have a beam initially. Oops, sorry. You have a beam initially like oops. You have a beam initially like this, and then it says that the NC is displaced 10 millimeters downward. Yeah, so it's like this, 10 millimeters. So if you simplify, it's from like this to here. So this is 10. Okay. So there is a wire here. There's a wire here. This is 3 meters. This is 4 meters. Okay. So the wire EC, because it's shift downward 10 millimeters, so strain EC, E to C is the delta. What is the delta? Delta is 10 millimeters divided length, initial length from C to E, which is 4,000 millimeters. This is the strain. Okay, clear? Which is in this case 0.0, sorry, 0.00250 millimeters per millimeters. Okay, clear? So how about the epsilon dB? What is the delta for this one? You can calculate using interpolation, right? If this is 10, because the length is 7, yeah, from this point to this point, what is this? X, if the length is 3. You can easily calculate, right? X is how much? 3 over 7 times 10, right? This is how you interpolate. It's 3 over the total length times the total displacement 10, right? While once you get this, how big is it? I forgot. I think 30 divided by 7, it's 4 comma something, 429. So it's a 429 divided by what is the original length is also 4 meters. So then you can get the strain is 0.00107 millimeters per millimeters. Okay. Any questions? Okay. So this is what we have learned today. Yeah. So we learn stress, we learn strain, and then we learn Hooke's law. Yeah. We solve several problems on solving the the strain for each like this. So you're given a problem, but then you're given directly the displacement of C. All right. In some cases, it will not be that simple. This is something that you need to find. For example, let's see next questions. Do you think you can solve this? Can you do the same approach as before? Determine how much it stretch. So it asks you what is the strain here. Can you solve it? No. Yeah. In this case, you cannot solve. Why? Because they give you the load P 3 kilonewtons, but you cannot know what is the displacement here because it's not given in the question. In the previous question, it is directly given. Delta is 10, so you can calculate. But in this question, at problem 4, you're given the load, so you cannot know the delta. How do you know the delta? Can someone tell me? So first, if you know the load, how do you calculate? You calculate the N. What is N? Can someone tell me what is N? N is internal forces. Once you know the internal forces, what do you calculate? You calculate the stress, which is N divided by A, the stress of this guy, right? Once you know the stress, what do you do? Oops. What's next after calculating the stress? Calculating the strain, yeah, which is the sigma divided by E, yeah. So this is called, how do you call it? Hooke's law. Okay. In the previous questions, you're given directly the delta, so you can calculate directly the epsilon. But in this case, you cannot do it. You need to do it one by one. Any questions? So I will skip this part first. We're going to see this again. But what I want to show you, yeah. So let's continue with the Hooke's law. Yeah. So in the Hooke's law, E is the modulus of elasticity. So elongation is associated with the transverse contraction. So when you have a cube, you try to pull it like this, it will elongate in the x direction, but it will shrink in the y and z directions. You know why? This is called Poisson contraction. Sorry. It's called Poisson contraction. Contraction. Okay. So how big it contracts is determined by these parameters called nu. This nu is called Poisson ratio. Okay. So the Poisson ratio, if you see here, it it relates the strain in the transverse with the strain in longitudinal. Okay. So imagine I tell you that the nu is 0.3, and then I told you the length originally 10, and delta L is 1. What is the strain in this case? Can someone type? The strain long longitudinal. Can someone type? What is the strain here? Delta L divided by L0. This is 10%. Yeah, this is 10%. If nu is 0.3, what is the shrinkage in other direction? The shrinkage in other direction is minus nu divided E long, which is 3%. Okay. Any questions so far? So I hope it's clear. Yeah. So when you do a tension in one direction, the dimension in other direction will shrink due to this what we call Poisson contraction. So how big it will contract, how big it will shrink, determined by a parameter called Poisson ratio. Okay. So so what we learned before, for example, sigma E times epsilon, this is called Hooke's law, but this is one-dimensional Hooke's law. In real case, we never live in 1D case. Yeah, the real world is three-dimensional. So in three-dimensional, the Hooke's law is given like this. Yeah. So because you have sigma x, you have sigma y, sigma z. Yeah, you remember before. This is three normal stress. Yeah, normal stress, there are three. And then you also have another stress that is shear. Yeah, the shear stress, and shear stress. Yeah. This is called Hooke's law in 3 dimension. We're not to discuss a lot on this, but I just want you to know that there are 6 stress components. So in Hooke's law for 3D, the equation is given like this. Yeah. But the one that we usually solve for an exam, it's limited to 1D. Yeah, 1D where is E times epsilon. Okay. This is 1D and this is 3D. Okay. Clear? You don't need to remind this. I don't think it will be in the exam. Yeah. But I just want you to know that this exists. Okay. So this is the generalized Hooke's law in 3D case. Okay. Any questions? So next week, we are going to continue our study on axially loaded member. So what we learned before is you have a beam, you have a bar, you give a load, let's say P, you calculate the stress. Oops, sorry. You calculate the oops, you calculate the stress, which is P divided by A. This is what we learned so far, right? And then we can also calculate the strain. L0 delta L divided by L0. Okay. So next week, what we learn is that how to calculate the displacement if you have, for example, a beam like this, how to calculate the delta. Yeah. And then we can see we can see several problems next week. And for example, like this, and then we try to solve the one that I just showed you. You need to know the basic of displacement of axially loaded bar. But I think that's enough for today. I will try to give you homework. Yeah, homework because you have so many homework that I haven't paused in the LMS. So you have homework on internal forces. You have homework on normal stress, axial load, and then about what we have learned today. I think that's enough for today, Dr. An.
Okay, thank you, Dr. Dito.
Okay, thank you, Dr. An.
Okay, see you next week. Dạ thầy xíu.
xong rồi đúng không?